6-4C, Applications of Systems of Linear Equations, Part 2. Same objective as last time, but now I'm going to work on traveling and coin problems for this lesson, okay? So traveling, flying, current, and water, all right? These kind of problems often come up, all right? So I'm going to focus on air problems, all right, in the airplane. Going usually in class, I'd have this big long conversation about flying, but for the video, I'll just cut it short. If you fly from west to east, like California to New Jersey, you actually it's faster because there's wind that's always at your back. It's called a tailwind, and so your airspeed plus that wind speed, that equals what we call our ground speed. Ground speed is what we know as our speed, 55 miles per hour when you're driving a car. So if your airspeed, is 500 and there's a wind speed of 50, the ground speed will be up to 550 because you would just add those two together. That's from west to east. But if you're going east to west, you're actually flying into that same wind. So you would have to subtract it away. You would have to subtract your airspeed from the wind that you're flying into, and that will be what your ground speed would be equal to. All right, so pretty much A is your airspeed, W is your wind speed, and G is your ground speed. And going west to east, you can add them together. Going east to west, you're going to subtract those. All right, so here we have a problem. A traveler flies from Charlotte, North Carolina, all over to California. Same exact time, somebody leaves California and is going to Charlotte. All right, so they're both leaving at the same time. The airspeed of both of these planes is the same. Airspeed is the same. Ground speed are shown. All right, so the ground speed for the eastbound plane is 550, and the ground speed for the westbound plane is 495 miles per hour. I want to know, what is the airspeed and what is the wind speed? Since both airspeeds are the same, they are equal to each other. All right, that tells us the airspeeds are the same, so we can say they're equal to each other. So here's the LA plane going towards North Carolina. If I take the airspeed plus the wind speed, it equals 550. All right, based on the previous page's information. Can you come up with the equation for the other plane going towards LA from North Carolina? Hopefully you came up with very similar. A minus W equals 495. All right, instead of A plus W, we got to subtract away that wind speed. So now we have these two equations. What do you think we should use? Which method do you think we should use in this case? I hope you didn't say substitution or graphing. We should probably eliminate, because my A's are the same, my W's are opposite. I'm going to choose to add my two equations together. When I'm adding my two equations together, my A's don't cancel out, but my W's do. And I'm now left with 2A equals 1045. All I'm going to do is divide by 2, and I get the airspeed to equal 522 miles per hour. Well, now, what about the wind speed? How am I going to go about finding the wind speed? Well, all I need to do is plug in, all I have to do is plug in this 522 into either here or here and solve for W and get that. So go ahead and go and do that. Hope you got 27.5 miles per hour. And that's how you do one of those style of problems. Again, they're going to all be a little bit different. I mean, I can't do them all, but there we go. Now let's do a coin problem. Neil has 23 total coins, nickels and dimes only. All right, some are nickels and some are dimes. He has a total of $1.55. How many of each coin does he have? You could just guess and check, and eventually you'll get it. I don't want you to guess and check. All right. What we want to do is create two equations. One of those is about the number of coins Neil has, and the other one is the amount of money he has. They're different, but they both need to use the same variables. And I'm not going to use X and Y in this case. All right. We know that the coins, the number of coins, he has dimes and nickels, total 23 total. We know that if we add the nickels amount plus the dimes amount, we get $1.55. So what variables do you think I'm going to use instead of X and Y? I hope you said let D equals the number of dimes and N equals the number of nickels, right? Because if I do the number D plus N, dimes plus nickels, I get 23. Now you got to think about this. How much is each coin worth? All right, a dime is 10 cents, nickels 5 cents. So now here comes the second equation. This is often a little more challenging for students, so I'm not going to make you fight too much for it. I'll kind of put it out there and just give it to you. If I take the number of dimes and times it by 10 cents, 0.1, and the number of nickels, n, times it by 0.05, that will equal $1.55. So now, looking here, what method do you think we should use? I'm going to use substitution. All right, what I'm going to do is I'm going to solve one of these equations, not the one with the money in it, but the number, just the end of the D, and I'm going to solve it for D. I'm going to subtract n from both sides. So I now have D equals 23 minus n. All right, so the number of dimes is going to equal 23 minus n, the number of nickels. And what I'm now going to do is I'm going to substitute this value in for D in this equation. All right, but I'm going to do it down here. I kind of have it nicely written, I hope. So 10 cents, which is this from here, times D, but instead of D, substituting 23 minus n, plus 0.05 n, plus $1.55. So now looking just at this equation, the only variable is n. Sure, it's a long, lengthy equation, but we can still solve it, all right? I'm going to distribute my 10 cents to 23 and 10 cents to negative n. That gives me 2.3. I'm not going to read through the whole equation, but there we have it. What I'm going to do next is combine my like terms, and that gives me negative 0.05. My next step, I want to isolate my n, so I got to get rid of this this 2.3, $2.30, and that leaves me with negative 0.05 n equals negative 0.075. Since we have negatives, is this an uh-oh? Is this going to be a viable solution? Can I have negatives? Is this an uh-oh? No, it's not. We have to divide by a negative 0.05. When I divide by a negative and a negative, I get a positive. All right. There are 15 nickels. That means there are 15 nickels in there. How many dimes are there? Well, all I need to do is go back to one of my original equations, 15 nickels, go back to one of my original equations, and I want you to tell me there's one of my original equations. I like this one right here. Let's use this one. Tell me how many dimes were there. Hope you got 8. And that's it. All right, those are a couple different styles of problems. The workload for all of 6-4, though, notice there was no work yet. So the workload is going to be IXL U15. There's a Khan Academy assignment, and then your mastery check. Also, I added an aspire to do, not a lesson, but aspire to do practices. Those are extra practices that will help. They're individual application problems, all right?